Welcome to a new Bitcoin Books video. Today, we're diving into the document that started it all, Satoshi Nakamoto's original white paper, Bitcoin, a peer-to-peer electronic cash system.
You see, at its heart, the paper was proposing this really radical new way of thinking about digital money. And it all boils down to one powerful idea. It's not about trusting a person or some big company, it's about trusting math.
But, to really get the solution, we first have to understand the problem Satoshi was trying to solve. So in this breakdown, we're going to walk through the core ideas from the paper. We'll look at the problem with trust, what a new kind of coin even is, how they solve the whole double spending thing, the genius behind proof of work, what makes the network tick, the incentives, and finally, what a system without trust actually looks like in practice.
All right, let's get right into it, starting with the fundamental flaw, the real weakness, and how online payments used to work. Before Bitcoin came along.
Think about it. Every single time you buy something online with your credit card, you're putting your trust in a bank or some other financial institution. Satoshi pointed out that this whole trust-based model has some pretty big weaknesses baked right in. For one, transactions can be reversed. That means banks have to step in and mediate disputes. And guess what? That costs money. And those costs make tiny casual transactions like, say, tipping a creator a few cents almost impossible. Plus, merchants are forced to ask for tons of your personal info just to fight fraud. And even then, a certain amount of fraud is just seen as, the cost of doing business. There was just no way to do the digital equivalent of handing someone cash.
So the key takeaway here is that any system built on trust needs a middleman, and that middleman is expensive. Satoshi's big idea was to completely replace that middleman with something else, cryptographic proof. So let's check out how this new system gets built, starting with the very definition of what a coin is.
Okay, so the first step was to completely rethink what an electronic coin even is. In Bitcoin's system, it's not some file you can just, copy and paste. It's a history, a record. Think of it like a digital baton in a relay race. Each owner passes it to the next person by digitally signing off on the entire history of that baton's journey and then adding the next runner's name to the list.
So let's break down how a transfer actually works. It's really just a simple, three-step cryptographic handoff. First, the current owner uses their private key, which is kind of like a secret password that only they know, to sign a message. That message basically says, hey, I'm giving this specific coin with its entire past to this new public key, which is like the recipient's public address. Then, that new info just gets added to the end of the coin's data. And here's the cool part. The new owner can now look at that whole chain of signatures and prove with pure math that they are the one and only rightful owner.
Okay, so that gives us secure ownership. Awesome. But it doesn't solve the biggest problem in all of digital cash, right? What stops me from taking that digital baton, signing it over to you, and then immediately turning around and signing it over to someone else too?
Yeah, that is the double spending problem. And figuring out how to solve it without a bank or some central authority getting involved, well, that's the absolute core breakthrough of this entire paper.
So to stop someone from spending the same money twice, the whole network needs to agree on one single shared history of every transaction that has ever happened. The paper basically describes it as a global town square. Everyone announces their transactions out loud for all to hear. The first version of a transaction that the crowd hears and agrees on is the one that becomes official. Any attempt to spend that same coin again later is just flat out ignored.
And this public timeline gets built using a really clever idea, a distributed timestamp server. Today, we just call it the blockchain. Here's how it works. Imagine you take a whole batch of recent transactions and you stuff them into a digital box. Then you run that box through a special math function called a hash. This gives you a unique fingerprint for that box of transactions. Now, to create the next box, you have to include the fingerprint of the one that came right before it. This forges a chain, right? A blockchain. And because of this, if anyone tried to change something in an old block, it would break the entire chain that came after it. Tampering becomes super obvious.
And this leads us right to the next big challenge. In a totally decentralized network, with no boss, no CEO, no central clock, how does everyone agree on what the next block in the chain should be?
The answer is probably the most famous part of the entire white paper, proof of work. You can think of it as a voting system, but instead of one person, one vote, it's more like one CPU, one vote. The network makes everyone compete to do some really intensive computational work. Basically, they're all trying to solve an incredibly hard digital puzzle, and the first one to crack it wins the right to add the next block to the chain.
Now, the real magic here is that this puzzle is super hard to solve, but the answer is incredibly easy for everyone else to check. It's this imbalance that makes the whole thing secure. See, to go back and change an old block, an attacker wouldn't just have to resolve that one puzzle, they'd have to redo the work for every single block that came after it. And they'd have to do it all faster than the entire rest of the network is building on top of the honest chain. It's practically impossible. That's why the longest chain is always considered the real one. It simply has the most computational work, the most proof invested in it.
But that raises a good question, right? Why would anyone volunteer their computer's expensive processing power to do all this hard work? Well, this brings us to the economic genius of the whole system.
Satoshi built in two key incentives to get people to participate, and, this is crucial, to play by the rules. First, you have the block reward. The computer or node that solves the puzzle and adds the next block gets rewarded with a batch of brand new Bitcoin. The white paper itself compares this to gold miners using resources to discover new gold. The second incentive is transaction fees. People sending money can attach a small fee, and that also goes to the miner who includes their transaction in a block. This is what's designed to keep the network secure in the long run, even after all the new coins have been mined.
This whole incentive structure is brilliant because it makes being honest the most profitable thing you can do. I mean, even a super greedy attacker would quickly realize it's way more profitable to just play by the rules and earn those rewards than it is to try and attack the system, which would only end up devaluing the very coins they're trying to steal.
So how secure is it really? Well, the system is secure as long as the honest participants control more computing power than any potential attacker. An attacker would have to get their hands on a majority of the network's power, that's the famous 51% you hear about, just to have a fighting chance of creating a fraudulent chain faster than the honest one.
But here's the thing. Even if an attacker had a ton of power, trying to rewrite old transactions gets exponentially harder the farther back in the chain you go. Just look at this table from the paper itself. If an attacker has 10% of the network's power, you just need to wait for 5 new blocks. We call those confirmations, and their chance of pulling it off drops to almost zero. Even if they had a massive 45% of the power, after 340 confirmations, their chances are still practically nil. Time is definitely on the side of the honest chain.
So let's just recap what Satoshi's system actually created here. What we have is a peer-to-peer network with no single point of failure. We have coins that are defined by a secure chain of digital signatures. There's a public history that prevents anyone from double spending. We have proof of work, which acts like a lottery to decide who gets to update the history. And finally, there are powerful economic incentives that make sure everyone stays honest. It really is, just as the paper says at the end, a system that's robust in its unstructured simplicity.
So by weaving all these ideas together, the white paper didn't just propose an idea, it laid out a complete blueprint for a truly trustless electronic cash system for the internet. And it leaves us with a really powerful final question to think about. If we can replace these trusted third parties in something as important as finance, what other parts of our digital lives could be transformed next? For those of you who want to learn more, the link to get the book is right there in the video description. And hey, if you found this content interesting, please do subscribe to the channel and hit that like button. It really helps us reach as many people as possible. Thank you.